Hello and welcome everyone, my name is Grégoire Petit. I am the first author of the FeTrIL paper, co-written with Adrian Popescu, Hugo, David Picard and Bertrand Description, and I am very happy to be here today to present it to you. I'll divide my presentation in three parts. First, the context, setup and motivation. Second, the description of the method. And third, I present to you the result compared to other methods, as well as the key takeaways. Let's get started. Let's start with the context, the setup, and the motivation. I think it is good to define the class-incremental paradigm in contrast to the classical paradigm. In the classical paradigm, the model learns on the whole dataset, whose 6 classes are represented by the 6 different colors on the screen. Whereas in the class-incremental paradigm, the model learns as the states arrive. In this example, we have 3 states, each composed of 2 classes. At each state, we compute the accuracy on the classes already seen cumulatively. Generally, we take the average of these accuracies over all the states. As you may have guessed, there is already a specificity of this paradigm. In the classical paradigm, as the dataset is learned in a single pass, the output classes are of comparable magnitudes. Whereas in the class-incremental paradigm, if nothing is done, having only access to the current classes, then the past classes are forgotten. This is catastrophic forgetting. Now that the context, the setup, and the motivation are defined and presented, it is time to present FeTrIL. To do this, we place ourselves in the latent space of our backbone trained on the first state. Let's take an example with 2 states of 2 classes each. We are in the first state, 5 images of the square class and 4 images of the round class pass through the extractor, and the features are placed in the latent space. We then classify in 1 versus rest mode. We evaluate on the test. Then, instead of storing the classifiers, we store the centroids. We now switch to the second state. Place the past centroids, calculate the new ones, and calculate the distances between them. We then take the minimal distances and perform a geometric translation, which allows us to classify all the accumulated classes. Let's move on to the third and last part, the results and the key takeaways. I benchmarked FeTrIL against the state-of-the-art methods that have results on some datasets. We noticed in bold that although FeTrIL is very simple, it is really performing. It should also be noted that in the case of one class incremental learning, FeTrIL works and is also very efficient and not very sensitive to catastrophic forgetting. It is now time to conclude. Here are some key takeaways. Concerning FeTrIL advantages, FeTrIL is embeddable since it has low requirements in terms of computation and memory. FeTrIL is much simpler and more effective than mainstream distillation-based methods. FeTrIL is usable for one class incremental steps, and FeTrIL performance is close to that of exemplar-based methods. Concerning FeTrIL limitations, it is dependent on the domain shift between the initial fixed model and the subsequent data. Initial classes are favored over the rest since the fixed model is trained with them. The pseudo-feature generator could be learned for a more refined representation of past classes. I thank you for your attention. I will be happy to answer your questions, and you will find all the FeTrIL materials on my website displayed on the screen.